Okay, my recommendation here is to rewrite this in terms of sines and cosines. And the secant is actually 1 over cosine. By the way, that does present trouble for me right now. I'm not too worried about the troubles. And the tangent is going to be sine over cosine. And then I'm going to combine that together. You get cosine of x. And on top you get 1 minus sine of x. And certainly a variety of things I could do with this, but right now I'm just looking at it. And, I'm going to try to do it without L'Hopital's rule. Let's put this down. Limit x goes to pi over 2. 1 minus sine x over cosine x. I can multiply the top and the bottom by the top's conjugate. So 1 plus sine x. 1 plus sine x. All right, what do you get there? Limit x goes to pi over 2. And on top you get 1 minus sine squared, which is cosine squared. I'll repeat that. If you took this, multiplied by that, they're conjugates, you get 1 minus sine squared, which is cosine squared. What do you get on the bottom? Cosine x times 1 plus sine x. All right, what happens over here? One of the factors of cosine cancels off. And again, we're not using L'Hopital's rule to do the problem now. What do you get? Cosine x. And on bottom you get 1 plus sine x. What's the limit at the top? It's 0. What's the limit at the bottom? That's going to be 2. And 0 divided by 2 is just simply 0. We're expecting to get 0. All right, so that's one way to do it. And the other way to do it, let's go for that. I'm going to erase this business over here. This is me using what I was able to do from the past. Now I want to use L'Hopital's rule. All right, let's put this down. The limit of the top is 0. The limit of the bottom is 0. So I can use L'Hopital's rule. Or at least try to use L'Hopital's rule. And derivative top is going to be minus cosine of x. Derivative bottom is going to be minus sine of x. What do you get here? Relatively simple. As you go towards pi over 2 for cosine, it's going to be 0. And the bottom would just be minus 1. So you still get 0. All right? Thank you.